Conjugate acids and bases. So we've talked a little bit about identifying what's an acid and what's a base, and we'll probably spend some more time on that. But let's talk about something that can help us identify what an acid and a base is, because each acid and each base has what's called a conjugate, a counterpart. That is, if we have an acid, it has a counterpart or a conjugate base that goes along with it. And if we start with a base, we'll have a conjugate acid that is related to it. So I've written two generic reactions here. The first one is for some acid, and the second one is for a base. So let's talk about the first one that is about an acid. So right here we have HA, which is an acid. And it's reacting with water to form its conjugate base form, A minus, and H3O plus. So in this reaction, HA is acting as our acid. Water is acting as a base because it picks up the proton. Our A negative is related to our acid. Notice how it's just missing an H plus. This is the conjugate base. And similarly, actually, H3O plus is our conjugate acid for water. It's very useful to remember the relationship between an acid and its conjugate base. That is, most of the molecules actually right here. It's only one H plus different, right? We've lost an H plus to get to the base form. That can help us identify what is an acid and what is a base in a chemical reaction, because we can look for the transfer of a proton and be able to see that most of the molecule will not change. Similarly, down here in our base reaction, we have our base B. Now, in this case, water is acting as an acid because it is going to give a proton to the base. Now, this is the conjugate to our base. It's the conjugate acid. Notice how it has one more H plus than our base does. That is one of the ways to identify them. And in this case, hydroxide is our conjugate base to water because water acted as an acid here. So there's some examples, just generic reactions that can show you the relationship between an acid and a conjugate base, or a base and its conjugate acid. But let's have some actual chemical reactions to help explain this. So let's choose formic acid. Formic acid is the simplest carboxylic acid. There's a carbon. There's a hydrogen. Double bond to an oxygen. And an OH. So here is our carboxylic acid. And let's react it with ammonia, one of the simplest nitrogen bases. So and we'll have an equilibrium here. So here's our acid. Here's our base. And then what it will form is the conjugate base of formic acid, which is called formate. It's just this ion minus an H plus, so we lose this particular hydrogen. Not that one, that one's very well bound to the carbon. Here's our conjugate base of formic acid. And then we'll form the conjugate acid of ammonia, which is the ammonium ion. There's the conjugate acid. Notice that in this case we've lost a proton. We've gone from having the proton here and we lost it. So now we have a negatively charged molecule here because we lost an H plus in the conjugate base. And this base has picked up a proton to become the conjugate acid. And that is now NH4 plus. So one more proton. And since protons are positively charged, it has a positive charge on it. That is one way to identify conjugate acids and bases. Now, in the case when we have started with a weak acid or a weak base, the conjugate base and the conjugate acids actually have some strength to them. However, if instead we had chosen, say, a strong acid like hydrochloric acid and a strong base like sodium hydroxide, then this isn't much of an equilibrium, and I'm trying to draw a smaller arrow on the bottom, but the marker is making it larger than I want. So I'll just make the bigger one bigger. That's to indicate that the reaction is going to go much more forward than it will go backwards. But in any case, we're going to make water plus some Cl minus and some Na plus. I'm separating these two, and hopefully you'll see why. So right here we have our acid, and here we have our base. And over here it's a little bit harder to determine what's what. In this case, our H plus and OH minus have combined to make water, a so-called neutralization reaction, plus some salt, NaCl. This chloride, though, is actually the conjugate base for that acid, right? Because we've lost an H plus. So in this case, this would be considered the conjugate base. And make no mistake, this is a terrible base. It has almost no acid-base qualities about it because in order for this to be actually a base, it would have to become a strong acid, and this reaction is just not going to go in that direction. But, you know, technically speaking, this is the conjugate base. it's just horrible at it. And now we have to identify what picked up or what gave the proton, or what could give the proton over here. Which of these species could be the acid? Well, if this reaction were to go backwards, the only place protons could come from is the water. And so I suppose this should be called the conjugate acid. Now, again, it's not a very good acid. And in cases where a strong acid and a strong base react with each other, normally we don't even think about it too much about the conjugate base or the conjugate acid. But there they are. And you might say, well, what's the sodium? It's nothing. It's a spectator ion. In fact, a lot of people would write this excluding so-called spectator ions and just write the net ionic equation. And the net ionic equation for every strong acid, strong base reaction is the same. It's simply just H plus OH minus making water. Every last one of the strong acid, strong base. Net ionic equations are this. The net ionic equation for the example up here is actually just the equation because every one of these ions participates and is not a spectator. But here, this chloride is already somewhere else in solution, and so is the sodium. And so really the only ions that would matter in this case are H plus and OH minus, making water. And water is generally considered to be a neutral species. It's not an acid or a base, just on its own. If something else interacts with it, then it could become an acid or a base, as we saw earlier in this video. That's just a little bit about conjugate acids and conjugate bases and how to identify them and look for where the proton came from, where it's going, where it could come from over here to identify what is an acid and what is a base.